Hello and welcome to Mr. Thompson's Math Tutorials. Today we're going to be looking at the difference of squares. The difference of squares. Actually, this should have been S right here. Okay, let's look at this. We're going to FOIL it. So if you remember how we do FOIL, FOIL was first, outside, inside, and then last. And that's how we expand this this right here. Okay, so when we start with FOIL, we're going to multiply the first times the first. Okay, so I'm going to do that right now. That would be x times x. Okay, and then we're going to multiply the outsides times the outside. So this is the outside, and that's the outside. So I'm going to be multiplying, let's see, plus x times 3. Then we're going to be multiplying the inside times the inside. So this is the inside and that's the inside. So I'm going to be multiplying, let's see, -3 times x. And lastly, I'm going to do the last, right? So last, so that's going to be this one times that one. So this -3 times this +3. So -3 times +3. Okay, so now I'm going to just collapse this back together, and let's see, over here I get x squared. Here I get 3x, so that's plus 3x. Here I get minus 3x. And here I get, let's see, -3 times +3 would give me -9. Now, I can simplify this just a little bit more. I see that right here I have a positive 3x and a -3x. Well, that gives me 0. So basically those go away. So I end up with x squared minus 9. Okay, now that's important information for us. Whenever we see this situation where the numeral, the number in these terms, in these factors here, are opposites of each other, so I have -3 and +3, or -4 and +4, I'm going to end up with this situation that essentially I'm going to end up with only the first times the first and the last times the last. The outside, the middle part, these parts right here, essentially cancel each other out. So those are the parts that I can almost forget about. So let's look at this. If I'm looking at the difference of squares right here, oh, gotta clear my ink. Clear ink. Okay, so I look at the difference of squares right here. This is a difference of squares. This is a square because x times x is x squared. Okay, so that's a squared, and this 9 here is really 3 times 3. So again, that's a square number. Those are perfect squares. Remember, our perfect squares are 1 times 1, which is 1, 2 times 2, which is 4, 3 times 3, which is 9, and then 4 times 4, which is 16, 5 times 5, which is 25, 6 times 6, which is 36, 7 times 7, which is 49, 8 times 8, which is 64, 9 times 9, which is 81, and 10 times 10, which is 100. You could go on, like, 11 times 11 is 121. But it's really important that you recognize the perfect squares at least till 100. Okay, so that's that group right there. So I should recognize that this is a perfect square. This is a square number, that's a square number, so it's going to follow that same sort of pattern that we saw earlier, that if I was to factor this thing, I would end up back with my x minus 3 and x plus 3. But let's just verify that that's in fact true. So we've thought about this whole idea of unfoiling things, so if I think to myself, okay, let's start with the first. I know that this is going to end up in the form of some sort of variable plus some sort of number times some sort of variable plus some sort of number. Okay, this is the way that we've been factoring, sort of by looking at what's in the middle. So I have to think, what are all of the factors of -9? And I think of what are the factors of this. So what two numbers multiply together to give me x squared? Because that's what's going to go here. Well, that would be x and x, right? So those are easy. This 9, I have to think of the factors of -9. So -9's factors are 1 and -9. Let's see, -3 and 3. And I think I got all of them. Oh, probably -1. Okay, so I need to think about which of these, if I put them into these empty spaces, are going to give me what's in the middle here. Now, there's nothing in the middle there. So actually, there is, though. There's a 0x in the middle. This is really the same as 0x minus 9. Because 0x is 0. I don't need to write it, but it's there. I can put it in there. I can add as many zeros as I want to things. But so I know that this middle term right here is 0. Okay, so I need to think to myself, which factors can I put in here? Which of these factors can I put in here and have their sum equal to 0? Well, 1 times -9 will give me -9, but -9 plus 1 is going to give me -8, so it can't be those ones. Okay, let's see. Then that leaves me with -3. Oh, and I could also have this +9. Sorry, I forgot about that one. So -1 times 9 is -9, but 9 minus 1 is still 8, so that's not going to work either. So that leaves me with these two. And if I think to myself, -3 plus 3, well, that's 0. So that must be what's in the middle here. So I'm adding a -3 and a 3. I can get rid of this plus sign right here. Okay, so yes, that verifies that we're back at this point right here. Okay, so we should see a bit of a pattern going on here, and the pattern is this. That if I have a difference of squares, so that is, in the case that we just looked at, x squared minus 9. 9 is a square number, x squared is a square number. So if I have a difference of squares, when I factor it, I'm going to end up with this situation. Okay, I'm going to end up with the x, basically the square root of the x, the square root of the 9, which is 3, the square root of the x minus the square root of the 9, which is 3. Okay, and this is always going to hold true. But let's check it out in a couple other cases. So let's move on to this one right here. Let me clear my ink. Okay, so I have this question right here, and I can see, well, I've got one square number there because x squared is a square number, and 25 is a square number, and I'm finding the difference. So that means that I get this situation where I'm going to find the square root of x squared, which is x, the square root of 25, which is 5, times the square root of x squared, which is x, minus the square root of 25, which is 5. Okay, and this is factored. Okay, let's look at it in another case. Here's another case right here. This is a squared number and that's a squared number. Now, how do I know? Well, I know 25 is because we just saw that. X squared is a squared number, but also 4 because 4 is 2 times 2. So this would be 2x minus 5, or plus 5, sorry, times 2x minus 5. And I've managed to undo that difference of squares. Okay, let's look at one more example. Okay, so here we go. Last example, I have this. Now, I think to myself, 20, x squared is a squared number, so that's okay. But 20, is that a squared number? No, it's not. Not a squared number. 125, no, not a squared number, because I know that 11 times 11 is 121, and 12 times 12 is 144, so 125 is in between there, so it's not a squared number. But can I factor anything out of both of these? So I know that 20 is actually equal to 5 times 4 times x squared minus 125 is equal to 5 times 25. So I can actually pull out this 5. So I pull this 5 out, and I end up with 4x squared minus 25, which is basically the last problem. And we know the answer to the last problem was 2x plus 5 times 2x minus 5. Okay, and that's factored. Thanks for watching.